Okay, 12 o'clock. Welcome in, ladies and gentlemen, to the second of two mandatory meetings for you to discuss what's coming for you in senior design for next year, 2022-2023 school year. So thanks for joining me. This meeting is going to be recorded. I'm going to post it to YouTube later too if you'd like to review it again later, just so you can do that. So keep an eye out for that if you'd like to review it again. You're here because you're interested in learning about the projects for next year, and so thank you for coming. And let's just get started. So we have to talk first about how you're going to provide your preferences. After this talk, I'm going to email all of you a link to a form where you can fill out all of your project preferences. I'm also going to send you a PDF of this presentation so that you can look over them with a little bit more detail. There's also a link there in the PDF that I'm going to send if you'd like to go to the form to fill out your preferences that way. But please fill out the survey by next Friday, okay? So you have a week to do it. Once you fill it out, I will match you with people that you might want to work with, projects that you might want to work on as best I can, okay? If you don't fill out that form, you might not get the project that you want, and you might not get to work with people that you want, okay? So fill out the form. Oh my God. All right, so let's get into the projects. First, we're going to talk about industry-sponsored projects or industry-affiliated projects. And so these are projects that you'll work on here with some ME professor, but are also going to be sponsored by some outside entity, for instance, Milwaukee Tool. And the first one that we have on the list is a project from Milwaukee Tool. They have a device for clearing clogs in drains that uses air pressure. It's kind of a newer device that they're working on, and they want a test fixture to help them test their device. So you will work with Milwaukee Tool in pretty close tandem to design a test fixture to help them evaluate the performance of their tool. And not only will you develop the test fixture, but if you're successful in that, you can provide design input on the tool itself if you get some information back from your test bed. So I think this would be a good project if you're interested in fluids. Air is kind of a fluid in this case. Mechatronics is good because you're making sort of a test fixture, and so getting data back and integrating data sensors with an Arduino and that sort of stuff. I think that would be kind of a fun project, and you get to work with Milwaukee Tool. So that's kind of a cool one. Next, there's a composite manufacturing company right up the road. It's maybe about 2 miles away from here, north. It's near UWM's campus, called Cornerstone Composites. And they manufacture all sorts of cool fiber reinforced composite parts. And one piece that they make is a piece that you see here in this image. This is called an icon connector. It's used in the fabrication of like large factories, like Amazon warehouses and things like that. What it's used for, not all that important for you to know, but this company manufactures a lot of these. We're talking thousands and thousands of them. And they come off of the mold, and what you see there, a picture like what you see there, is the product. And the product has these additional plastic on the outer edge of it called the flash. It's not the comic book character that you're familiar with. It's a different kind of flash. This flash is all this plasticky stuff around the ends. And the operators at the company need to kind of like scrape that stuff off by hand in their current process. And so Cornerstone wants the ME senior design team to design a fixture that can very quickly remove this flash from products that come out of their molds, okay? So if you've got interest in composite materials, if you've got interested in fixture design, things along that sort, robotics possibly, if you want a robotic solution to sort of take off this flash, that would be cool. Another thing is that this company is offering internship positions for anybody that might need an internship for the 2022 summer. So you could work there for the 2022 summer, then work on a senior design project next year related to this item. And if you do an internship there, you'll see how this thing is made. You'll probably deflash it yourself by hand. You'll get the idea of how kind of annoying that is. If you're interested in that internship opportunity, please send me an email and I'll give you some more information. Okay. Next, Rockwell Automation. This is a continuation of a project that's been going on for 2 years now. You will work with Dr. Cook, who is, consulting with Rockwell Automation. Dr. Cook is a part-time faculty here because he works part-time at Rockwell also. And they're designing a robotic arm to retrieve modules in a harsh environment. And so MSOE is sort of helping them with the controls and the material selection that go into this robot. So you can take a look at this robot. It's kind of on the main floor of the science building, kind of near where all the fluids labs are and things like that. And they're near completion, but they just kind of need another year on the project. So kind of a cool project if you're interested in like mechatronics and controls and robots and all that sort of stuff. Continuing, ProX. So ProX is a small produce company, actually. I mean, they make a lot of things and do a lot of things, but one thing that they do is they make devices to help get produce to where it needs to go more efficiently. And so they're asking to partner with MSOE to create a modular fruit washing device. Okay, it's a little bit strange, but you know, if you're into fruits and vegetables or whatever, or plants, this might be for you. So imagine like a tiny, I envision kind of like a tiny little chamber that you put like one apple or one orange or one banana. You got some water that washes this thing off, and the dirt gets collected and brushed away somewhere, and etc. So they're asking for a device that's modular, meaning that you could have one or you could have many in a long array that sort of work in tandem together. So I think this could kind of be a cool design, especially if you're kind of like a nature buff and you like fluids and process efficiency and that sort of stuff. Next, for those of you who play basketball, Alyssa, maybe this is the project for you. Dr. Troutman is partnering with the Pro Lane, which is a basketball academy, more or less, based in Waukesha. And so the Pro Lane has a facility, a gym, basically, that they use to train young individuals who are interested in getting better at basketball. And so they want to partner with MSOE to make two different devices. One to improve your stance during shooting of a basketball, and the other to work on hand rotation and shoulder rotation during the shot of a basketball. So I am back. Check, check. Can you guys hear me?
Yeah, we can hear you.
Okay, where did we leave off?
Basketball.
Basketball. All right. Apologies for that. Let me share my screen again. Okay. Dr. Rizza every year has groups of students that work on biomedical applications. So Biomedical is pretty big with Dr. Rizza. He teaches a class on medical devices. And so year after year, he proposes a design group to build and construct a brace of some kind or a prosthetic or something of that, orthotic, something of that nature every year. In the past, you see an image here of something that was designed. Do we have issues still? We good? Can you guys hear me?
I can hear you.
Yeah, okay. I'll keep going. So they have designs of these 3D printed medical devices year after year, 3D printed. So if you're interested in medical applications, 3D printing, this might be for you. It's not quite clear what exactly you're going to be working on quite yet, but it's usually something pretty cool. Back brace, for instance, right here, people in the past have done things for like boots for people that have that need like a leg brace, things like that. So a lot of interesting stuff. 3D printing, if this is for you, maybe you want to go this route. Okay. ASME design competition. Every year, Dr. Mahinfla has a couple of groups that usually participate in the ASME design competition. So design competition for ASME, you don't quite know what you're going to get year after year again. Usually they release the competition prompt around the fall timeframe, but you will probably be constructing some device to achieve some goal. In the past, they've done like football playing robots. This most recent year, the design competition was to design a mobile device that was powered by water slowly falling. Okay, so like put water in a basin, and the basin slowly can be used to power your device. So kind of interesting stuff. MSOE has traditionally performed quite well. Placed first and third last year, which I thought was pretty cool, and traditionally has been quite good. So if you're interested in mechanical design, robotics, mechatronics, etc., this might be the right path for you. Keeping with the competition theme, Dr. Rodriguez always enters the National Fluid Power Association Fluid Power Vehicle Challenge. This is an idea of creating a vehicle that gets powered by some sort of fluid power or fluid energy. Here you see a project from a couple of years ago. This is a bicycle that was retrofit with like a fluid pump to sort of propel the bike using some fluid power. So I think the team that built this actually won first in the competition, which was pretty cool. So if you're interested in fluid power, power transmission, instrumentation is also kind of important for this particular project. This might be the project for you. Sticking with the competition theme, still. Every year I have at least one team that enters into the AIAA Space Mission Design Competition. And again, the prompt for AIAA Space Mission Design doesn't come out until about September-ish or August, something like that. But if you're interested in space, you don't really get to like build anything, so to say, with this particular project, but the prompt is usually something like design a spacecraft to land on Mars, okay? So you go through like the full design process of the life support systems, the structure, the propulsion, all that cool stuff. Every individual person kind of gets their own subsystem and kind of work on a spacecraft, basically. So one of my teams this year is like 3D printing their final spacecraft to demo, which is going to be kind of cool. So that's the general idea. Projects in the past have been things like design a spacecraft for landing on Martian moons, so Phobos and Deimos. Or the year before that was design a lander to land and collect an ice core sample from Mars. So pretty interesting stuff. So if you're interested in astronautics, space mechanisms, and space generally, maybe this project is for you. Again, keeping with AIAA and the design competitions, Dr. V also enters the AIAA design competition, but he enters a different design competition, not the space mission design, which I do, but the engine design. So AIAA also hosts a competition for aircraft engine design. So previous projects have included the redesign of the Concorde hypersonic jet engine. So the Concorde is one of the first hypersonic jets that was commercially available for people to fly on to go from location to location. And another previous project has been design of a bypass turbofan, which is kind of cool. So if you have interested in energy topics, engine design, etc., this might be the project for you. Dr. V has stipulated, though, that if you're going to pursue this project, you have to take compressible flow in the fall. That is ME4802 as one of your technical electives. So if you're going to be on this project team, you must take that class. Okay. If you're interested in space generally and those previous ideas didn't really appeal to you, maybe you're interested in something that Dr. Swedish does every year, which is some unknown NASA projects. So Dr. Swedish has a buddy at NASA that he works every year with to do a couple design projects. You never really quite know what they're going to come up with. You know, Dr. Swedish is a little bit of a mad scientist, so never quite know what he's going to come up with. But he usually has 1 to 2 projects every year on space-related stuff. And so flavors of projects that have occurred in the past include automated system for watering plants autonomously, like on a timer, and design of a stowage system for food packs and foodstuffs that's more efficient. So kind of interesting ideas. So if you want to take kind of a gamble on space-related projects, maybe this one is for you. So you're interested in space. Yeah, space. Okay. Other things. I'm also interested in creating a new benchtop buckling demonstration apparatus. So any of you that went through the ME 3005 class and did the buckling lab, it's not the best lab, let's just say that. You're buckling very long, 18 inches or so long, 1-inch thick pieces of brass. You don't love it. And the current machines that we use are outdated and don't measure well, and they don't align well. And anyone that went through that lab knows that it's not the best, let's just say. So I would like to design a tabletop buckling device that's, you know, fits on a table and, you know, yay big, something like that, that can demonstrate these buckling concepts a little bit more repeatably and a little more safely with lower loads, smaller samples, to make the lab a little bit better. That's really what I'm looking for. So if you like mechanics materials and you like design of experiments, maybe this one's for you. All right, moving on. Dr. Severe, he's very involved with Engineers Without Borders. More recently, he went to Guatemala to help the Guatemalan community sort of upgrade their cardamom dryers. So cardamom is a spice that gets sold and exported out of Guatemala. And so the Guatemalans use the spice industry in their economy significantly. But the machines that they use to dry their spices are rather inefficient. And so Engineers Without Borders went down to Guatemala and investigated their dryer, and I think Dr. Severe has identified a number of ways that their dryers can be improved. So here you see a Guatemalan individual standing next to their dryer that they're operating. This picture was taken by Dr. Severe, showing the machine that needs optimization. And so you'll work with Dr. Severe to design a new machine or design optimizations for the machine that currently exists. And who knows, maybe you'll take a trip down to Guatemala. I'm not sure. But if you're interested in sustainable design, cost-effective solutions, thermodynamics, fluids, heat transfer, all that good stuff, helping out in third world countries, maybe this one's for you. All right, back to aircraft and flight thingies. AIAA also has a design build fly competition called DBF for short. And Mark Fleming wants to advise a team for the DBF competition. So design build fly is a competition, again, that's put out by AIAA every year, where you as a group will design an unmanned area vehicle to accomplish some task. And the task for each competition each year varies. So when the wildfires were going on a couple of years ago, their design prompts for AIAA was to create a UAV that could automatically fight wildfires, which I thought was pretty cool. More recently with COVID, they decided to have a prompt of delivering medical devices to places that might need them using a UAV. So drone delivery, more or less. So kind of a cool project. You know, the department has funding to help you build your device, so, or your aircraft. So always kind of cool. If you're interested in like RV planes, aerodynamics, aircraft design, those sorts of things, that's cool. If you took Aero as a junior this quarter, I don't know if there is anybody that did, but Fluids 2 is actually the only requirement for Aero. So if you're taking Aero with Dr. Comiskey right now, this would be a pretty good project for you generally, if that's something that you're interested in, okay? All right, moving on. Dr. Vyas and Dr. Lim have proposed a project of energy harvesting, and specifically they want to harvest energy from waves. So waves in the ocean or on any fluid, there's some energy associated with that, and you can capture that. And so Dr. Vyas and Dr. Lim want to create an energy harvesting device for harvesting energy of fluid waves. So kind of cool if you're interested in fluid mechanics, energy harvesting, power systems. This might be a good one for you. You have to have completed fluids too for this project. Okay, moving on. The construction and architectural engineering and construction management department has contacted the ME department in need of the design and build of a new piece of lab equipment to help them study fluid flow on like a street. Okay, so fluid runs into a gutter. It's a rainy day today. Maybe you can observe this outside today. When it rains, I don't know what the weather is in Germany right now, by the way, but for those Germans joining us. But today in Milwaukee, it's raining, and the rain is flowing in the street and flowing into a gutter, and the construction management and civil architectural engineering want to study this phenomena in a lab, and they want the MEs to help them design some apparatus that can show that. So here's a picture from the proposal that Dr. Ganwa had sent to me. Basically wants to make a device that simulates this flow and how the water flows in these gutters. So if you're interested in more civil-minded things or fluid flows, design of experiments, maybe this one's for you. Keeping with that trend, Dr. Ganwa also has another piece of lab equipment that already exists in CC50, which is kind of where they have their fluids lab for the construction management people. They have basically like an Earth simulator, which is kind of cool. It's this big table. You can sort of see a picture there. It's maybe, I don't know, 12 feet long by 8 feet wide. It has a bunch of sand in it, and it's meant to simulate like terrestrial landscape. And they have all these like rain heads above it to simulate raining conditions, and you can orient the sand in certain ways to get landslides, and you can vibrate this table and so on and so on. But he's told me that there's a couple of issues with this particular machine. Like some of the heads are clogged on this guy, the vibration doesn't work, and so implementing or refurbishing this would be part of the senior design process for somebody that might be interested in this. So heavy controls and mechatronics for this, because you're going to have to understand kind of how the vibration of this table works and how the rain heads operate. There's probably some solenoids in there that you need to understand and work with. So fluids too, you might be delivering water through their rain system, etc. But I think kind of a cool project. You get to like simulate earthquakes and stuff. I think that's kind of cool. Okay. The Baja team is the team that constructs the vehicle that you see there in the lower right-hand corner. It's a little bit of an older picture, but that's a Baja vehicle, and every year MSOE has a Baja team that competes in the sort of competitions that are national in the US. And Dr. Sebastianovich is the leader of the team, and he's always looking for updates to the design of the vehicle. So he's got 3 target groups in mind for this upcoming year: redesign of the engine, redesign of the suspension, and redesign of the drivetrain for the Baja vehicle. He likes to work with teams of 2, so 2 working on suspension, 2 working on engine, 2 working on drivetrain. But I've seen him work with groups of 3 as well. So if this stuff interested you, if you're kind of a vehicle person, maybe this is something for you. Okay, so this is the faculty proposed project. We did have one student proposed project by Jack, and this is the design of a sort of a environmental housing for animals, so for rabbits. The team for that is kind of already established, but if you're interested, maybe they'll take one more. I'm not quite sure. But if you're interested in heat transfer sustainable design, maybe you want to indicate that as some of your preferences. Okay, so that's going to do it for the talk. I'm going to email this deck out, and I'm also going to email a link to the form for you to fill out your project preferences. And when you're filling out your project preferences, I'm going to ask you to rate every single project on a scale of 1 to 5. So I get an idea of kind of what you like and what you don't like. I'm also going to ask you if there are individual people that you want to work with for your project. So if there are, please make sure to indicate those. I will also ask if you prefer a 2-term project or a 3-term project. Some of you might be graduating in the winter and are required to do a 2-term project. And so please, I have a question about that. Please indicate that. I also ask if the project that you work on is more important than the people that you work with, or if the people are more important than the project that you work on, or if you don't really care. And that helps me sort of give priority to if there's a certain project you really love and you can't stand not doing that project, okay? And if there's a certain person that you absolutely must work with and you love that person and they're your bestie, okay, but maybe you won't get the project that you love. So keep that in mind when you're filling out the form. That's it for the talk. Do we have any questions in the chat or from anybody before we close the meeting? Okay. If not, good to see all of you guys. I'll email all this information out and fill out your project preferences. Bye-bye.